So we did the first 3 steps of glycolysis. Hexokinase catalyzed the first reaction, turning glucose into glucose 6-phosphate. And then phosphoglucoisomerase catalyzed the second reaction, turning glucose 6-phosphate into its isomer, fructose 6-phosphate. And then the third reaction was another phosphorylation, just like the first reaction, turning fructose 6-phosphate into fructose 1,6-bisphosphate, using the enzyme phosphofructokinase. Now, what I did over here was I drew fructose 1,6-bisphosphate. This is, remember how fructose open chain was carbon 1, carbon 2 is the carbonyl, carbon 3, carbon 4, carbon 5, carbon 6. You're not going to have to worry about structures, but I just wanted to show you what's going on here, because this next step turns the 6-carbon molecule into 2 3-carbon molecules. We're going to cut it right here. So this is going to become a 3-carbon molecule, and this is a 3-carbon molecule. The enzyme involved in turning fructose 1,6-bisphosphate into 2 3-carbon molecules is an enzyme called aldolase. Aldolase. The way I remember it is that it ends up turning one of them into an aldehyde. So let me show you what the 2 products are. I'm going to just go ahead and move this here. This becomes an aldehyde. And this is a ketone. So these are the 2 molecules that are produced. This one is glyceraldehyde. Remember glyceraldehyde? A common name. Actually, you guys remember glycerol. Glycerol was 3 OHs. Glyceraldehyde is an aldehyde that has the 3 carbons. Glyceraldehyde 3, this is carbon 1, 2, 3, 3-phosphate. And this one is dihydroxyacetone phosphate. So remember, acetone was 3 carbons with a carbonyl in the middle. So this one is called dihydroxyacetone phosphate. Sometimes we abbreviate it DHAP. So anyway, reaction number 4 is catalyzed by the enzyme aldolase. The substrate is fructose 1,6-bisphosphate. The products are glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, 2 3-carbon molecules. Now, if you count all the carbons, all the hydrogens, all the oxygens, all the phosphorus, you will find that these 2 guys are isomers. They have the exact same molecular formula. So in the next step, what we're going to do is we're going to take this DHAP, this dihydroxyacetone phosphate, and convert it into glyceraldehyde 3-phosphate using an isomerase enzyme. So the next enzyme is Triose phosphate isomerase. You know what? I'm just going to erase all this, and I'm going to write DHAP, which is dihydroxyacetone phosphate, and the enzyme is Triose phosphate isomerase, and then it turns it into glyceraldehyde 3-phosphate. So we already had one glyceraldehyde 3-phosphate, but now we have another one. So from now on, we're going to have 2 of everything. We had 1 glucose, which turned into 1 glucose 6-phosphate, which turned into 1 fructose 6-phosphate, which turned into 1 fructose 1,6-bisphosphate. And then the fructose 1,6-bisphosphate got turned into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. But then the dihydroxyacetone phosphate got turned into glyceraldehyde 3-phosphate too. So now we have 2 of these guys. Okay, so starting with this next reaction, it will always be double. We're always doing 2, because in the end, we're going to end up with 2 pyruvates. Now, so far, have we produced any ATP? No. But pay attention. In the first enzymatic reaction, number 1 and number 3, we had an input of ATP. So we had to put ATP in to get the whole thing started. So you've already used up 2 ATPs. Remember, at the end, we have to have a net output. After everything's said and done, we have to have a net output of 30 ATPs. We're not even anywhere close to that yet. Okay, we haven't produced any. All right, so the next enzyme is a really important enzyme. This is enzyme number 6. This is glyceraldehyde 3-phosphate dehydrogenase. Okay, just from the name of the enzyme, dehydrogenase, this is an enzyme that catalyzes the removal of hydrogens. And anytime you remove hydrogens, if you remember from organic chemistry, that's a redox reaction. It's an oxidation. So glyceraldehyde 3-phosphate dehydrogenase catalyzes a redox reaction. Flutter back here. All right, so what is going on? You've got glyceraldehyde 3-phosphate. And remember, I drew glyceraldehyde 3-phosphate for you guys. How many of them do I have? I have 2 of them. There's a phosphate here. I have 2 of them. Okay. Everything's going to be doubled from now on. Remember how I told you guys some enzymes have coenzymes? Well, this enzyme has to have NAD as a coenzyme. Remember, NAD is derived from the B vitamin niacin, which is vitamin B3. NAD stands for nicotinamide adenine dinucleotide. So with this, we're going to have an NAD plus charge to it. And we're also going to have an inorganic phosphate. PI is an inorganic phosphate. It's a source, you know, whenever you eat food that has phosphorus in it, it can produce this inorganic phosphate, PI. So the substrates of this reaction are glyceraldehyde 3-phosphate, NAD, and inorganic phosphate. Now remember, when you oxidize an aldehyde, you turn it into a carboxylic acid. So we're going to turn this aldehyde into a carboxylic acid, but it'll be a carboxylate ion, so the name is going to change to glycerate. So we're going to produce, our product is going to be, this is going to change its structure. It's going to be a carboxylic acid, so it's a carboxylate ion. But then this inorganic phosphate is going to hook up right here. So my product is going to be 1,3-bis phosphoglycerate. 8 meaning a carboxylate ion. Sometimes, like I said, I would call it diphospho, but your book calls it bis, so that's fine. All right, so what does the NAD do? Well, in all of this, it picks up a couple of hydrogens. So the NAD becomes NADH, H+. Okay, and if you look at your book, hopefully that's what they have as one of your products here. Yep, NADH, H+. All right, so this is enzyme glyceraldehyde 3-phosphate dehydrogenase. The substrates of this enzyme, this is enzymatic reaction number 6. The substrates are glyceraldehyde 3-phosphate, NAD, and inorganic phosphate. The products are NADH and 1,3-bis phosphoglycerate. Everything is 2 of them. So I have 2 of these producing, 2 of these and 2 of these and 2 of these producing 2 of these and 2 of these. Okay, so far we produced 2 NADHs. This is a big deal because the NADHs are going to go over to the electron transport chain, and they're going to be the reason we're going to be making a whole bunch of extra ATPs at the end in the electron transport chain in the next chapter. But right now we're just doing glycolysis. We're on the 6th enzymatic reaction of glycolysis. The next video will hopefully wrap up the rest of the reactions of glycolysis. Okay, all right, we'll finish this up.